Okay, so on this question, they're wanting us to multiply these. So let me bring it down here. So 2 square root of 3 times 5 square root of 15. So how do we do it? How do we multiply? How do we times a couple of different roots? Well, if we were, by the way, if we were adding or subtracting, we could not. We would just say, hey, they're unlike roots. We're done. You can't do anything. Right? We know that you can only add or subtract like roots. You can only add, subtract like roots, but you can multiply or divide any roots. Any roots go. And if that seems weird or like you might have trouble remembering that, no, I bet you won't have any trouble because it's exactly the same rules for x's. Think about x's. What if we had like 2x times 3x squared? And what if you had 2x plus 3x squared? These are unlike, and you just leave them. You can't add them. You can't make it 5x cubed, but you can multiply them, huh? It'd be 6x cubed, right? You just multiply 2 times 3 is 6, and x1 and x2, you just add the powers, right? So it's exactly the same rules. The roots are the same as the rules for letters, right? We can only add, subtract like roots, and same thing goes for letters. You can only add or subtract like letter patterns. It's got to be the exact same power. Whereas you can multiply or divide any roots, you can multiply or divide any letters. 2x and 3x squared, doesn't matter. Just multiply the numbers in front, add the powers. We don't care whether they're like or unlike, just multiply them, right? That's the same exact rules. So let's do it. 2 times 5 is 10. And what's going to happen with it now when it comes to the roots? Could I just go 3 times 15 is 45? You could, absolutely. Nothing wrong with that. But it's going to be easier instead. Well, let me put it this way. If you did that, if you made that 45 right away, right? Everybody see what happened right there. The outside numbers multiplied, 2 times 5 is 10, and the inside numbers multiplied. That's right. There's nothing wrong with that. But what would you have to then do? You'd have to start breaking down that 45 right away. What would be your first step? 3 times 15, which is what it was already. You see? So you might as well not do that, right? You're just going to undo your own work. So just go ahead and make it 3 times 15. And that'll be one step towards breaking it down already. Since we need to break down roots, we might as well not multiply them and make it 45, right? If your goal is to take Humpty Dumpty apart, you might as well not put him back together. Are you tracking with me? Right? 3 times 15 is 45, yes. And you could make that 45, yes. But you need to take it apart, right? Because roots, we do the 2 for 1. So you might as well just leave it partially apart rather than make it 45, and then just keep going on your simplification. This is 3 times 5. Bring down the 3. So we have 3 times 3 times 5. So this becomes 10. And then we have the square root of, oops, I meant to do, there we go. 3 times 3 times 5. You tracking with me? So what have we done so far? We can multiply any roots. You just multiply the numbers in the front and multiply the numbers in the roots, right? Outside numbers multiply, inside numbers multiply. But when you do the inside numbers, instead of multiplying 3 times 15, just write 3 times 15, and because you got to break it down. And break it down all the rest of the way, and then you know what square roots do. They're a 2 for 1 deal. So 2 3s inside. Sends 1 3 outside, it multiplies. And so that's going to be 30 square root. And what's left on the inside? 5. And there's our answer. 30 square root of 5. So again, you can only add or subtract like roots, just like with letters, but you can multiply or divide any roots, just like with letters. You multiply outside numbers times outside, inside times inside. But when you do the inside, just leave them as they are because you got to break them down, then send out the 2 for 1, 30 root 5. There we go.